Hello, everyone. Thank you for joining this meeting. Let's get started. So today's session is around retrieval-augmented generation. We will go through this slides, and if anyone has any questions, you can feel free to post those questions in the chat. And others who join this meetup. So if you are aware of the answer to that question, please feel free to join the discussion, because it's not, one-man show. I'm here just to create and build a community where everyone learn and grow together. So feel free to jump in if in case, if you want to add to any of our discussion through chat, and we will have a discussion session once we are done with presentation. So let's get started. So today we are going through retrieval augmented generation. And today's discussion is aligned with someone who's very new to Gen AI, but at least they should have a bit fundamentals around how LLMs work. But we still covered that, but we're not covering in depth on how large language models work, or how ChatGPT works. I might use LLMs to be ChatGPT because it's easy that way. And a lot of them might have just used ChatGPT, but ChatGPT is not, and ChatGPT is a product from OpenAI. So I might use ChatGPT while presenting, but ChatGPT is not an LLM. It's a product powered by large language model, but just so that there are a lot of users of ChatGPT, I just want to use that in a way that everyone can understand, someone who's coming from a non-technical background as well. So let's get started. First, let's go through what are the problems with LLMs, or something like ChatGPT, and how retrieval augmented generation helps um, with with overall research process, or how it can help with the limitations of these large language models. So, I mean, I don't know if how many of you trust ChatGPT, but there are a lot of issues, which have happened through relying too much on these large language models. Some of the incidents being some fabricated legal citations that happen, where a attorney was actually was pointed out in court. There were a lot of fake court incidents that ChatGPT created with high confidence. There were a lot of misquoted sources for journalism. If journalists are relying too much on it, there might be some incident that ChatGPT might have quoted which never happened. There's also a lot of incorrect medical advice. It's dangerous, but yeah, there is a chance of ChatGPT giving out some incorrect medical advice. So this is ChatGPT, or these large language models are not perfect. They are mostly a human language simulators and probabilistic. So they're just predicting the next word, but it doesn't guarantee that. And the fact that the fact that it's generating is right all the time. So inherently, this is the biggest problem with large language models. And hallucinations, we call them hallucinations if in case there is a incorrect information that it is throwing out, or maybe less citations, like it's not giving you the exact citation from where it has got that information. There could be a lot of outdated knowledge, because ChatGPT or large language models, they are only trained up to a specific point in time. So ChatGPT might have been trained only up till April of 2024, or maybe some point of time last year, but these models are not continuously trained. So there is a very high chance that they might not know some latest information. I mean, nowadays ChatGPT can give you latest information, because they are basically using different tools to do that. Basically, they have a browser that access the latest news and provide that into ChatGPT, and it basically they do RAG. That is what they do, and that's what the session is about. That is how you're able to get up to date information. But inherently they do have this problem of outdated knowledge. It's called knowledge cutoff problem. So where they are not aware of recent events. They do have inconsistent, unreliable context is the biggest issue. Sometimes, they cannot completely understand the context. It could also be due to prompt engineering because, if your prompt is not detailed enough, then they give you, a wrong answer. And limited verifiability. I mean, definitely these are black boxes. There's still very less observability involved. There is very limited explainability. So we don't know exactly how it came up with that answer. So these are inherently the drawbacks of ChatGPT or LLMs. And I think there are a few of them that RAG can actually solve. And why these exist? I mean, LLMs, large language models, are actually pattern matchers. They're very good pattern matchers. They're very good human language simulators, which they are trained on all of internet. So they are aware of lots of um, uh, lots of human data generated, so they're very good at mocking that. So they lack true understanding of real world, and they are static because they only are pre-trained certain point because they're very costly to train these models. That's the reason why most of the AI companies are fighting are going behind data centers or energy like nuclear power so that to power these training or data centers to continuously train these large language models on. And there is also a lot of internet fact-checking information, right? Um, we get a lot of data from internet, but if um, it lacks grounded information. It is not able to provide sources um, in all by itself. So it doesn't have that mechanism to refer to sources. It just simulates its understanding. So yeah, just as we discussed, this is a black box. So these are the limitations that exist. That's the reason why these exist, because they are statistical machines. They are not. They don't have proper understanding of our real world. But what is retrieval augmented generation? So we have seen this as a simple workflow here. You ask a question, you just call your LLM or a question to your ChatGPT, and you get an answer. You start, you ask a question, and it's an end. But what if you want to have ChatGPT understand your own knowledge, maybe understand your own business documents, or maybe LLM already has good understanding about some of the medical domain. It might have already understand about medicine or maybe law. But you need to get a specific answer, but also sources to those answers. So how can you get that? Um, how can you get proper references? So given a question, when you make a answer or when you make a call to an LLM, you're actually providing the data to LLM. The data could be in multiple ways. It could be, PDFs, it could be, your internal product documentation, which LLM is not aware of because these documents are not on the internet. So these LLMs are not trained on the data. So they are internal to you. And you can actually send the snippets of the data to the LLM, augment this question, whatever question or whatever query you have with that additional data to an LLM, and then there you get the answer. So, and because LLMs do have large context length, so they can definitely fit in a bit more of your data while you're asking that question. So this is what retrieval augmented generation is. So you're augmenting the retrieval process and generating an answer. So that's what RAG means, retrieval augmented generation. So we are basically retrieving relevant documents first, then use them to generate more accurate answer. And these documents could be your internal documents, or it could also be some medical textbooks too, right? You are going to prescribe a specific medicine to a mental health problem. Maybe, there's DSM-5. I mean, DSM-5 is a Bible for everything to do with mental health. If someone has to prescribe a medication or CBT, it has to be referred with DSM-5 because every year new scenarios or new cases are added to it. So we need to able to refer to different sections of DSM-5 to come up with the conclusion. So we could use, maybe a textbook as one of the sources, which you can, based on your question, you can get additional context from the textbook, not complete textbook, but at least some important sections of it. Let's say if you're asking about, anxiety disorder, probably there could be some sections on anxiety disorder, and that would be augmented with your question and you get the answer. So you're basically going back, instead of relying on the LLM's probabilistic answers, you're providing it the factual reference where you're grounding the LLM to refer to that fact and then answer the question. So that's what happening here. So that gives the confidence that your LLM is answering from a source which is right, which is not, and so that your LLM is not making up facts. Rather, it is being grounded to some of the text coming from reliable sources. So that is what Retrieval-Augmented Generation, and they greatly reduce hallucinations by grounding the response. So that is what RAG is all about. And as we go through the slides, there are a few things that we probably need to learn. I mean, LLMs are probabilistic machines, so they don't understand text directly. I mean, they don't understand human language. They basically understand numbers. So they understand numbers, they do matrix multiplication, that's what's happening under the hood. So you can't directly pass your raw text to your LLM. Rather, there's some kind of pre-processing that should happen before sending this information to an LLM. What kind of pre-processing? So you need to understand what a vector database is, because large language models, they usually, every question that you ask, there is an embedding model that translates every word or every token. That is what they say, because it's basically predicting next word or next token, you can say, because a token may not always be a word. A token could be less than a word or more than a word. So so we need to convert this text into numbers and then send that information to a large language model. So that's great. I mean, this is something that maybe when you're doing in ChatGPT or you're sending in a question to ChatGPT, usually done on the fly. So ChatGPT does that for you. OpenAI does that for you. They convert your question into numbers before sending it to an LLM. But how we can do that with our own data, right? If we have our own text files, it's up to us to convert that. It's up to us to make this data something that LLM could understand. So that is where and that is where vector databases come into play, and also embedding models come into play. So these are some of the components that that are needed to build a RAG. I mean, if anyone has already worked with custom GPTs in ChatGPT, so RAG is basically something like custom GPTs. But even in that case, when you're building it, you're basically using a UI from ChatGPT. So you are not aware of all these things which are happening under the hood. But these are the things which are happening under the hood. There's a vector DB that actually stores, that creates embedding for your documents and stores it. And that's how you're converting your documents into numbers or embeddings before sending it to an LLM. But this is what's powering this custom GPTs, or in general RAG. I mean, I could just use custom GPTs to be something like RAG, because that is what they need. They just need some files, so you just upload them and they're just creating embeddings for that. So we could also do that externally. If you're using an LLM API like a GPT-4o or some other APIs, you could probably do that all by yourself. So what is a vector DB? So most of you might be already aware of a regular database. So a regular database would have a strict search. When I say strict search, you could if you go and search for a dog in your database, then it should have dog. Otherwise, if exact term with the exact case sensitive. So then you would probably, if there's no word called dog in your SQL database, then probably it says no data returned. But a vector DB, it is different in the sense that it stores every word as a vector, as the name implies, as a vector in a high dimensional embedding space. I mean, yeah, if you cannot get your head around this, if you're not technical, just try to understand, like, it's something where a dog, wolf, cat, all of these are animals. So these are all aligned, or these are all very nearby in a huge space of vectors. So if I search for dog, even if my database doesn't have dog, it will probably return cat or wolf, because dog is kind of similar in the categorically, they are pretty similar to animals. Banana and apple could happen to be nearby in the high dimensional vector space because they are coming under this category of fruits. So it's a high dimensional vector space that will have your representation of, it could be text, it could also be images or other data as well. So it could also be audio, videos too. People call it latent space. I mean, that where I mean, if in case there's a lot of I mean, latent space is a bit different in the sense that it is while processing, while LLMs usually do a lot of that in the latent space, a lot of matrix multiplication and all of those happen. But in this case, it's mainly a snapshot of it, where you have this representation of all of the words in a vector space. So you're converting our own document. So why do we need vector DBs? Because all these relevant snippets or your own documents need to be converted and ingested into this. So that's where the embedding model comes into picture. Embedding model is a model that actually converts every word of your document and maps them into and stores them in a vector DB in a similar way. So it's converting them and so that LLMs can quickly find any relevant information. So even if they are, framed a bit different. So you can say, okay, can you talk about maybe, my product catalog, a product catalog, something that is stored in your vector DB. It might be stored as product description, not exactly a product catalog, but still your LLM would understand, because your vector DB, it's not a strict search. It's more of like a geometrically similar vector searches. So it may not fail. It will treat a product catalog to be more of like a product description, or it can even take some other synonyms to that as well. So it can understand them. It can treat them to be pretty similar. It can treat them to be similar words. So that's how human language is, right? Human language is natural language is pretty ambiguous. They could be, you can say that I'm going to a bank, or a bank could be many things based on the context. So it could be a river bank, it could be a financial bank. So you basically need to have something that incorporates this ambiguity, and vector DBs are beautiful databases that can incorporate that, because of this, um, uh, because inherently they can store words within the vector space. And this is one of the architectures that that uh, that I want to show you exactly what's happening under the hood in this RAG. I mean, we have seen this. We have seen this part where you have the relevant snippets are sent to an LLM, but what's happening under the hood, or maybe more detailed description of this is this diagram. It's a beautiful diagram. It's from a Medium doc. I think I have the reference here. They're using a vector DB called MyScaleDB. That's what it is. It's there are a lot of vector database. There are a lot of vector search database. So there's Quadrant, VV8, Melvis, there's a bunch of them. Single store. So yeah, So what's happening is your documents are chunked. So it could be any document, it could be your textbook, your product catalog, it could be your own internal documents. It could also be any publicly available document as well. But even though LLM is aware of it, we still are using that as an external source. So you're chunking it. You're basically dividing that complete document into smaller chunks because you can't just feed all of the document into the embedding space. You're basically dividing them into different sections, and then you're using an embedding model to create embeddings for these chunks and store them in your vector DB. And this is the user query. So when you ask a query, usually the user query is also embedded through an embedding model. So the user query could be anything. You could ask a question about, what is my, how to get a refund for my product, or maybe how to get a refund for your product, which is actually, within your document somewhere. So user query, since there could be there's a word called refund in it, right? And it would compare that with some of the chunk. Maybe you might be talking about your product refund, in some page, maybe, 70th page, just to be some random page. And it just compares that with your documents. It just does a similarity search and looks for that chunk, maybe a 70th page, a certain section or certain chunk that is coming from the 70th page in this vector DB, retrieves that part along with your query, send it to your LLM to get a response. So hopefully you're understanding this. So what's happening is you're not feeding all of your documents. I mean, yeah, there might be a lot of people saying, oh, you can't feed your textbook because, these models can understand huge amount of data, but, I'll come back to that later, like how RAG actually both complements each other. But in our case, this chunk could be it could be of any other, your user query should carry the relevant information from your documents and send that to your LLM, and you get a response. So that's what happening. This is what RAG is. And we would also discuss about some issues with this complete architecture, but yeah, this is, as a whole, this is what's going on under the hood. And this is where your vector DB really plays key role. It's just about comparing your user query or your question to the existing documents. Yeah, this is also a different, it's the same architecture, but I added something called top K here. So basically, based on the user query, the chunks which are retrieved, it is not just one chunk, because the retriever is able to compare it. But as I said, this is all probabilistic machines. So you might not exactly get the same part which is answering about your refund for your product. You could also have other chunks which might be pretty similar to it, maybe something talking about your billing. So even those chunks are retrieved, but those are retrieved with less probability score. So that's the reason why the retriever is not just retrieving one chunk, but it might be retrieving a bunch of chunks, and it is only taking the chunk which is of high probability, or it could be retrieving few chunks which might be of higher probability. So maybe you might consider only something above maybe top five. Top five is top five chunks which are retrieved, which are for top five having high probability. And all of the times, don't expect that your answer would be in the top chunk. There are a lot of times where your answer could be in other chunks as well, and there is a chance that it might even like lose that context, because what you're doing here is you're just dividing your documents into different chunks. I mean, that's not a smart move, is what I feel like. I mean, document is robust. I mean, a document could have, it might talk about security, but the security could be of data security. It could be a security for your building. It could also be security for your personal possessions. So there's a lot of things going on in a document. There are a lot of terms which might be similar or they might be connected, but you're not capturing the true essence, true knowledge of your document. You're just chunking them, and you're asking your retriever to retrieve the top chunk. So you're just playing with numbers. So it might not be the best output all the time. So we'll address those issues, like how can you address those issues? But yeah, I'll just give a quick pause here before we go into top different types of racks to get some questions if there are any.
Can I?
Okay, yeah.
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 You said you're going to divide it into chunks. Suppose if they get it from multimodal, like a dog coming from voice and image and document, how do you integrate it into the same chunk
Yeah, that's
before
a
getting into the
that's a
embedding?
good question. Yeah, that's a great question, Ishwaran. I think we will go through that maybe later on.
Oh,
Um,
sure, sure.
because we are covering the multimodal RAG as well. So this is basically only taking one modality, which is about documents. So it's all the text chunks. But that's a good question. I would cover that pretty soon. Okay.
Thank you.
Yeah. Thank you. Any other questions anyone has?
Hey Raj, this is Suchindra. Hey,
Yes,
is there any limit is there for us to like, if I have like, thousands of documents, PDF document, like, to load. So is there any like, uh, max limit is there, or we can load any number of document, any
so
size of document?
there is no limit as such. There is no limit as such. You can put, thousands of docs. You can chunk them as long as you have capacity, compute to create embedding, store them in your vector DB. Um, and your vector DB also has indexers and all of those. But how big is your vector DB and also how much compute you have. But as I said, as your documents increase, then your accuracy decreases because now there are too many things to take care of, right? As documents increase, there'll be a lot of terms, a lot of new knowledge. So retrieving would be a challenge because now even to get this top K, probably your retriever has to do its best. Even while doing his bets, there is a high chance that you might not get the right answer with,
Okay.
just feeding in bunch of PDFs. And I'll tell you how to address that issue shortly. But
Okay.
just feeding
Okay.
like maybe, thousands of PDFs and ask it to,
Mhm.
hey, I give you this question, just answer it. Yeah, it might not probably give you the best answer, but it is possible to do that though.
Okay. Where is that price component comes in? Because suppose say like, I uploaded thousands of documents,
Yes.
I converted it to vector store.
Yes.
Uh, that price, like, where is that component will come? Like,
So the
when I'm.
price in the sense is the compute because now you need to chunk them and you're converting them to embedding models. So your each chunk, probably if it's PDF, you need to do OCR. So you need to have them into different tokens. You need to extract from OCR, you need to extract those tokens and you need to use an embedding model to embed them even there for that. Maybe if
Mhm.
you're using OpenAI model, then you have to
Correct.
pay for that. You should also pay for this chunking and OCR processing because then you have big data cluster if you want to do that in a distributed fashion. If you want to do that really fast, maybe process like, you have platforms like Databricks, they all
Mhm.
provide this where you can have this ingestion to do RAG. And then they might also charge for your vector store as well to store all of them or for your indexers, right?
Yeah.
RAG also have something called indexes, which need to index
Mhm.
all of your documents. So, and during the retrieval process, they might charge a bit there. So that's where all of the cost
Okay.
down to.
Okay. Good. Thank you, Raj. Thank you.
Any other questions?
Yeah, hi Raj. I have a question. This is Dev. I have
Yeah,
a question. When we are embedding, we have to provide the chunk size
when you're embedding, do you have
and
to?
the chunk overlap. Yeah.
Oh, chunks overlap. Yeah.
And my
Well,
challenge sometimes have been, yes.
yes. I mean, that's a good question. So it is better to overlap them. So what are you doing when you overlap? I mean, it's a strategy. So when you overlap them, you're trying to basically tell your chunk that there are certain parts which are linked. Let's say if you're talking about maybe a huge document, maybe your first two pages are about introduction, right? And you create maybe it's a 2-page document, you create 5 chunks of it. But how do you at least know that each chunks are interrelated and all of those chunks are part of your introduction section? So if you overlap your chunks, then, there is a way that you're telling your model that, hey, these are a bit more related to each other. So I feel it's a pretty raw way of doing stuff. I mean, there are some really smarter way, which we will, in the next slides, probably you will get answer to that question. But yeah, it's a
Okay.
it's a
Yeah,
best,
I'll wait for that then.
yeah, it's the best way to do that. People do overlap. Yeah. Any other questions so far? Maybe, yeah, I think it's the right time.
I had one question. When you're chunking the data,
Yes.
if you have like specific documents that are for a specific customer, how do you like basically add that to the chunk data so that when you ask a query, it basically, even though the data sets for all the customers are the same, you're basically pulling out just specific chunked, documents based off of like a specific customer that was like maybe included in the metadata or something.
Yes. So yeah, that's a good question. So basically you could add additional metadata in that case. So your data itself, your document itself, if they have, because in that case, there are 2 kinds of retrieval. There's called a sparse and a dense retrieval. So a dense retrieval is just like, when you have metadata, really some documents related to a specific customer, then you probably need to link this chunks into to additional metadata. You do incorporate that additional metadata where you do a regular search for that metadata and then retrieve the chunks related to that customer. So that would add up to your pre-processing as well. If in case, you have these docs, which, probably have everything in an unstructured fashion. And you could do that, or maybe you have these docs all stored in a structure, maybe in your data warehouse, where you might have your patient and also maybe some reports related to that patient, then you could probably do that as well. Like, you can search through your patient data information where you get reports which are linked to them, and then you get that information from that. But if the patient name is, or maybe I'm just giving an example of seeing patients, or maybe it could be a customer, it could be anyone, right? Your customer, if your customer name is within the document, right, we can't expect the vector similarity to do, vector similarity search would not just go and do an exact search of it. I mean, it can do the exact search within the document, but it is up to us to make that part of your pre-processing step, where you make sure that those chunks or those docs are, having this additional metadata incorporated to it. If it is not already done in a structured way, just like, having that in a data warehouse or somewhere. So yeah, that's the right approach. What you're saying, adding metadata would definitely help here.
So that happens during the embedding process. Is that how it works?
Embedding process is only happening for your unstructured data, which is your text within that document.
Yeah.
So embedding process would not take care of. Embedding process is just, in that case, what's happening is, through your user query, your retriever is only trying to get the metadata information, either through a SQL generation to get, maybe if it can just do a SQL search of it, which is deterministic search of that specific metadata. And then your embedding model was actually might have embedded all the details regarding that customer, which is unstructured data. And that is what goes into your LLM. So you're not just sending your customer information, your customer name to the model. You don't have to embed that, because embedding space, because you can't have like, maybe Raj and George in these vector space, because maybe your LLM would not understand how Raj and George are related, right? Because these are just names of some personalities, and probably it does its own guesses. So that's not smart. So we don't have to put our customer information in VectorDB. It should be external. Only the unstructured text data should probably be here into the VectorDB. And it could have an indexer, which is indexing that specific chunk of data that is related to your related to your customer, and that index could act as identifier for that chunk of information related to related to that customer. So that would be so vector DB has two kind of search. It's called dense search and a sparse search. And the dense search actually gets a deterministic value. So even if you're putting that in your vector DB, but if you're doing a dense search, it is basically doing a regular search.
I see. So when you do this, like, where do you put that like, what part of this process is that metadata inserted? Is it happening when you're doing this docs to chunks, or is it happening somewhere else? Like, is it happening outside this process or within this?
It can happen external to this. It doesn't have to be part of this exact process. So if in case during the pre-processing, if there is some unnecessary information, or maybe you need to filter out your PII because you might not need that information inside your vector DB. So so before the processing, your metadata is extracted. So it could happen as part of your pre-processing step, and they both can happen independently of each other. Like, it doesn't have to be together, but those need to be extracted and then tag your documents with that metadata. So it can be embedded along with the document content. So basically to create a more robust representation of these chunks into your vector DB. So that is how it can. So it can basically act like title to that, whatever you're working on. This chunks.
Got it. Thanks.
Yeah. Sounds good. Great questions, by the way. Yeah. So let me move on to the next slides, because there's a lot of interesting information. I think most of your questions would probably be answered by this. So yeah, I think there's data sources and indexing. Data sources, there are different kind of data sources. This could be PDF, CSV, API, and this is the thing which I really love, which is the knowledge graph. So we'll be talking about knowledge graph and how knowledge graph really helps us with with some of the drawbacks with chunking. So basically, I just want to give exact same thing here. What's happening here is just again repetition of this process. So here, if you see the different kind of vector DBs, I just want to give those names. Embers are created for chunks, and queries ember during inference. So inference is process where you get a response. So that's where your model is actually giving you an answer. That's an inference process, which is different than training. But yeah, this is the overall workflow. Do you have different data sources? There's also have different indexing strategies as well. So now let's come to different types of RAG. So this is a type of RAG called hierarchical RAG, or a graph RAG. There's a type of RAG. So the biggest problem with the chunking is, or even the question that was asked previously, where do they have to be any overlap between chunks, is just to retain the context. So given some documents which are really interlinked, interrelated, multiple entities are interrelated, or maybe you have thousands of PDF documents, which maybe each document talking about specific any specific thing. You could have some documents talking about your product data security, some talking about maybe some PDFs which are talking about your historical sales, maybe for different years, maybe for the past 10 or 15 years, and each year has its own PDF doc. So in order to retrieve, in order to use, if you just chunk them, the biggest drawback is you might lose some of the context, because chunks might not always retain the overall knowledge within the documents. So the best way to address that, or even the medical documents, because they could be different documents which will have different diseases, their symptoms, it could be the medications related to that. So everything is interdependent, right? So chunks would probably disrupt that correlation. The relationships, or the entity relationship, is usually destroyed through just plain chunking. So the best way to address some complicated domains like medical, or even where PDFs, it could be huge amount of PDFs which carrying a lot of context, you're basically creating a graph of your data. So I mean, this is a diagram which it could be, this is a diagram that is, I'm just showing like how to do graph rag. It is from a different source, but what they're doing is, they're just scraping data from multiple websites. They're doing a bit of cleaning, and then there is a database that they store this text, and then they're doing entity extraction. So entity extractions is basically building graph from that data. So if you have a lot of unstructured data, and if you create graph, a graph could be interconnected nodes with different entities. So it can create relationships between different parts or different entities within your document. What you're trying to do there is you're basically trying to build a knowledge graph, so which could be used by your LLM, and the retrieval can do a great job at retrieving entities, or understanding your document, and understanding different entities. It could be any question related to a specific disease. It can also get appropriate symptoms for that disease, because as part of your entity extraction, these are all interrelated. So you do a clustering of this, and then you do something called a community summary. So community summaries is nothing but a bunch of documents. Let's say it's something talking about a mental health disorders, maybe anxiety, or maybe other issues with stress, substance abuse. So each topic could be a community, and you just create a summary of that community, so that you can, whenever there is a user question, you are making use of that summary. Instead of going ahead and getting all of the PDF document, you just use that summary and also some entities within that. So you're basically doing a search, but mainly by traversing over a graph of your knowledge and then getting the output. So that way you're not just grounding, you're not just doing a similarity search, you're not just doing a geometrical search in VectorDB, but also navigating through this knowledge graph and getting the right answer. That's the beauty of graph rag. This will definitely take care of the issues with chunking, but the other disadvantage with this is there's a lot of pre-processing, because converting your documents into knowledge graph is not an easy process. There could be a lot of tokens that it can waste. Whenever a question is asked, you have to traverse to a lot of graphs. Maybe there's a lot of entities that you need to get relations with, that you need to send to your model. So they could be, even to create graph, you're again making use of LLMs to do that, right? You probably need to send it and ask, or even you can use maybe graph DBs like Neo4j and all of them to extract this. But you're basically wasting a lot of your tokens in the retrieval process. But advantage is you could get you get information which is really factually correct, and which is also which can also be auditable. We can definitely audit that retrieval easily just by seeing the traces of the graph travel, how the system went through this overall relationships between entities, and it is very easy for us to audit that. And there are a lot of companies already doing that. I think the few enterprises already implemented a system like this, creating a topologies and all of those. The next RAG is multimodal RAG. I think even we got this question previously. You might not expect your PDF to be just pure text. Most of the PDF would also have images. They would also have tables. They can have maybe charts, bar diagrams. There are a lot of data that a PDF could have, right? ideally, not every PDF would have just text. So that is where multimodal RAG comes into play. It's what it is. The advantage of this RAG is to accommodate other modalities. So as of now, we are only talking about some with images, not with videos and all. I mean, you could also do video RAG. It's possible to do that. Video RAG is just a bunch of images. So it's just about processing during the retrieval time that you take care of video RAG. But when you have this, when you can use, instead of chunking, instead of doing an OCR, you could directly take images of your PDF and feed it to your model. But not just raw PDF images, you still have to use an embedding space. You still need to have an embedding model, but it could be a different embedding model to do that. But the advantage of it is there's no need for you to do an OCR. You could directly just take plain images, or we call it various. You break down your single PDF into small boxes and different squares, and then put that into a vector DB. That way your model can actually respond to user queries. And how is it doing and how LLMs do it? It's because of multimodal LLMs. I mean, LLMs which can understand images as well, like GPT-4o, which is an Omni model, which can understand images as well because it has vision capabilities. So those are the models actually powering a multimodal RAG, where a model can also understand images, not just text. Call Pally, it's I think it's a great paper. If anyone has time, please read that paper. It's a beautiful multimodal RAG example, where every page, every PDF is basically images are created, and I haven't and there's different embeddings created. If you see every embedding with a tensor, they have a patch. So every image is broken down into many patches. So each image could probably be like 1028 patches. They are small patches which are created, and then these patches are put in an embedding in a vector space, vector database. So there's also a multimodal vector databases as well, which stores not just text but also images. And those chunks are sent to they are sent to your LLM to answer your question. So in Call Pally, it's basically a model called PalyGemma, which is a 3 billion parameter model. They are processing the entire page images. Okay, there's no need for you to do OCR. They're just like, it goes in, it just processes these images and puts that into your embedding space, and then you have it retrieves that. So this is the one which is actually retrieving those chunks, which is similar to your user queries. If you ask, okay, can you tell me about my sales data for this year, which is part of an image, then it is basically doing a similarity search with that, and then it is retrieving it. So it's capturing both. It's capturing the text and also the visual information. It's just not so your vision models can, if you take a screenshot of a paper and maybe you write something on the paper and ask your vision model to, hey, can you tell me what is that in this photo? Then your vision model would answer back and say, hey, this is what's written in that photo. Your photo, maybe you write in a paper saying, hey, what is my name? Take that screenshot, send that to a GPT-4o model and ask, what is that written in this paper? It will probably answer with more care. Depending on how well you write, it will probably answer that question. Most of the time it does a good job at saying, okay, you just written what is your name on that paper, because it's basically having that vision capabilities to understand the text within that image as well. So it's just blending both the modalities together and answering that question. So this is definitely a game changer, I can say, because now there's no need for you to do OCR, so you're saving a lot of money there. And you're also grabbing all of the rich PDF information, because your PDF could have images, it could have bar charts. So you're basically getting all that information as well. You're retrieving chunks which are related. Maybe you get these chunks together, the small patches of a whole diagram itself, and ask a question to your model and get your information from it. So yeah, this would be a great it's a great paper. It's online. You can read through it and just cover it, just off it. It's multimodal RAG, and there's no videos or others in here. I'm just covering images, but you could still have a video modality as well. A video is series of images. So when you're doing a video RAG, probably you could have a bunch of images which are stored internal to your database. Maybe you don't want your data or maybe your pictures sent to OpenAI, or maybe you want them stored securely in your internal database. And these RAG can actually detect when Raj comes into a video, right? You could just feed in a stream of videos and say, hey, where is Raj in this stream of videos? Maybe a 30-second snapshot of video, maybe like an hour-long video. It can do that, because what it is doing is a similarity search, but only thing it's happening is, each video is series of images. So it has to search through a bunch of images to get where Raj is. And it just does the similarity search there, because Raj features might be somewhere in that video stream, right? So that could be one more modality that can accommodate. I mean, yeah, and also speech as well. I haven't covered speech, but there is also you can also store audio as well in a similar way. But what changes? Maybe pre-processing changes. Maybe now there is a audio processing engine that converts that into, they might be a different embedding model. There might be a different vector DB that stores audio and convert that into an embedding space, into a vector space. So next thing is the self-optimizing RAG. I mean, this is really a beautiful RAG application. I feel this is the future of RAGs, which is self-optimizing RAG. A self-optimizing RAG is the biggest problem with RAG is the top K problem, right? There could be a lot of chunks which are pretty similar, but they might be having different responses. They might be having different context altogether. That is a huge issue that happens. So I have implemented RAG for various healthcare companies. So ideally, we could never say, oh, my RAG is perfect now. Everyone is happy. No, these systems are probabilistic. There are a lot of complaints when end user would say, hey, I asked this question, it gave me some random stuff which I'm not even expecting. I was asking about some security about this building, but it's giving me information about data security, which I'm not aware of. So, there could be different policies it is pulling because it's kind of similar, or sometimes it is just using its own knowledge. I mean, that is the biggest problem with RAG, because LLMs make up stuff because they are using their own knowledge. They're not grounding, they're not having facts checked from the data that you have. They're not answering questions from your policies, but there is a chance they make up stuff from something else. Maybe it is using its own inbuilt knowledge. We don't want that. If a RAG does that, then it hallucinates and user would get some random answer. And it happens a lot of times. I mean, if you just go with a naive RAG with chunking, probably it happens like 70% of 30% of the times it fails, depending on like what documents you have. So how do you optimize that? So that happens through a self-RAG. So self-RAG or self-optimizing RAG, what they do is they get this, it's very simple to understand. I mean, what's happening is you get this top K, and again, you just check for accuracy. How are you checking for accuracy? You again use a call to an LLM and say, hey, this question and this is the answer. Do you think they are accurate or not? Do you think they are similar, or do you think this could be the right answer? who gives that answer. It could be an LLM, or it could also be a human. Like you could put a box there where say a human says, oh, this is wrong. Now your RAG would go back and do a bit more refinement. Now it understands the previous retrieval was wrong. So it did a self-reflection of it, and now it doesn't repeat the same mistake. So they could be different hops, like it could be done in a first in only one feedback, or it could have series of feedbacks where it is repeatedly checking for accuracy and coming back with your response. Maybe, you get a response maybe after like few more seconds, maybe a minute, but you're getting the right response. So that is what a self-optimizing RAG is. It is checking back and getting a feedback. So, and this feedback could be done by human, or it could also be done by a different LLM. It is LLM as a judge, where an LLM is sitting there and checking for this accuracy, because it has some facts that is aware of within your own data. So maybe your RAG starts off with 70% accuracy, but as soon as it gets all this feedback, it keeps on optimizing. And maybe after 4 months of use, where different users are asking the various questions, it might be 95% accurate, might be 98% accurate if you're too lucky. So this is the beauty of self-optimizing. Like you're creating a different layer of this accuracy check, and then you're going back and getting back a different response. And there's one more, there's a new paper called corrective RAG. And yeah, that's what it does. It's just, you have retrieved, there's a grading process. It will check if there's a relevant documents, then yeah, if, yes, and it generates the answer, but no, it just transforms your query. And it does a web search if needed. I mean, this diagram is mainly meant for a pattern where you're probably getting an answer from internet, maybe some news. You're going out and asking about some news about iPhone. Then, it just checks for different documents that it crawled, and if there's a not relevant, then probably it will go back and transform that query or enrich that query. You just say, okay, tell me about iPhone. Or now you can, you can enhance your context. That is where transform query comes into picture. And this happens a lot with Perplexity. Perplexity does this, and behind the scenes, it's actually optimizing your own query. So they do a meta prompting of it, like they use your prompt and then make it a bit better, optimize the prompt to get relevant details and give you an answer. But yeah, this is I mean, I just put it as CRAG, but it's called corrective RAG. It's a recent paper that came out in 2024, late 2024. And oh, this is the other paper which is called reward RAG. This is also part of self-optimizing RAG. It's also a paper from, I think, September or October 2024. So what's happening here is basically they have created a reinforcement learning based RAG process. I mean, I don't know if how many of you are following AI, generative AI now, but reinforcement learning is changing a lot of things. I mean, reinforcement learning is definitely the leader in making RAGs, AI agents. I mean, OpenAI Deep Research. I don't know how many of you used it, but I'm using it. I love OpenAI Deep Research a lot. I mean, yeah, it's definitely pricey. It's $200, but I'm definitely saying it's worth for money. I haven't explored Grok. I should explore Grok's Deep Research. Perplexity Deep Research is definitely not that great. The Deep Research service from OpenAI is actually optimized by end-to-end reinforcement learning. It's beautiful. I mean, the way they do, you're teaching your model to efficiently browse to get the information. You're basically having a model do great research for you. I mean, the same thing has happened with Gemini as well. I mean, we all learn how deep research or how RL is playing, is really, having a significant role in even creating thinking models like DeepSeek. DeepSeek really proved us, saying that, hey, RL is what you need. End-to-end RL will actually make your model think and give you everything step by step. And I think RL will be applied at every place. And same thing here. They have created a reinforcement learning feedback loop You have this retrieval model. So it's a different model that is being trained just to make a proper retrieval. If you see in the other places where I talk about retriever, a retriever could probably be, you know, a top K chunks, which is basically doing a similarity search and giving out an output. But here, a retrieval model would actually be fine-tuned to do a proper retrieval. So it is specialized in retrieving proper documents. Then you have the GPT-4 evaluator. GPT-4 is evaluating this output on if this document is relevant, or it is moderately relevant, or is highly relevant. This is where, you know, the signals come into picture, right? This reward signals, you know, hey, you know, if it is not relevant, then you penalize this. If it is a highly relevant, you just reward it, right? So you have this model which captured the signals and send this back to your retrieval model to do further fine tuning. It was able to do proper retrieval. It is able to get relevant information all the time, then, you know, probably you give a positive feedback and your retrieval model, you know, doesn't need a lot of fine tuning. But if it's doing a lot of non-relevant one, then your retrieval model reward model get penalized, and, you know, you probably do a bit of fine tuning for your retrieval to better retrieve proper documents. So it's more of a proper feedback loop with RL, and amazing results. I mean, amazing results, and I think RL will play a great role going forward, even in fine tuning, and I'm definitely exploring that. We will have a session pretty soon, probably next month, around RL fine tuning. We'll be doing reinforcement learning fine tuning. Please look out for that session. So what are the future trends? I think the last slides, and then we'll go for discussion. So what are the future trends? There is a smarter reason and retrieval. Yeah, definitely there's you will see a lot of RL driven policies, just like how SmartRag or and also there should be symbolic reasoning. You don't have to do the reasoning in natural language, but you could also do that in a symbolic way, or you can also do reason through knowledge graphs, or GNNs, which is graph neural networks, which is a different domain of deep learning. And I really love GNNs, graph neural networks. Enhanced data ingestion and indexing. So this is where you would see more real-time multi-model indexing that still need to be improved. I think some question that was asked previously, what is actually pulling us back from implementing real-time multimodal indexing is basically some proper strategies, because there might be a lot of latency. So we probably need to improve that. So there could be more enhanced data ingestion research that is coming our way. I think there's a lot of researchers already doing great work. Log context and RAG. So there's a lot of talk saying, oh, RAG is dead because of this long context length. Gemini now has around like 2 million context length, I guess, in one of the recent models, I guess. If you have long context length, instead of doing retrieval of these chunks, why can't you just feed? Why can't you just feed? Sorry. Yeah. Just a minute. Sorry, there's someone here outside my gate. Just give me a minute. So thank you. So there's a long context length. Sorry, I keep getting these calls repeatedly. Yeah, are you able to see the screen now? Are you guys able to see my screen? Did I miss something here? Can you see my
We are able to see the screen.
Yes. Yeah, thank you. Someone knocking my door, but yeah. Yeah, there you go. So there's long context length and drag. There is even though you have long context length, you still need drag because you might have hundreds and thousands of pages that might get into your context length. If there's no proper RAG, then you might fight with the latencies, because when you're sending huge amount of data inflow and outflow, you're burning your tokens. So even though providers say, oh, I have this huge context length, you're basically burning your pocket, because every time input and output tokens, you're basically burning a lot of money there. So RAG is better because you don't have to send all of unnecessary information. RAG will still help you. So basically using a hybrid of both is a better option, and having a self-reflection will be a great trend. So I think that's what you will see going forward. And multimodal and domain expansion, yeah, we did see this. There's a lot of domain specific models that would come with few shot training. There's also continuous learning process. So you will have a self-optimizing with RLHF. There's adaptive retrieval tuning as well. RLHF is a reinforcement learning with human feedback. That's how ChatGPT was actually trained to imitate or come up with produce answers that are more human-like. Adaptive retrieval tuning for accuracy. That's also a future. A lot of papers which are coming with that, how the retrieval tuning is happening to enhance the RAG process. And user trust and transparency. I mean, all of this retrieval with proper mechanism to audit how and how the retrieval happened, it just definitely creates a lot of better transparency. We're not getting answers which are factually made up or which might be hallucinated. We definitely have all of those answers properly auditable answers as well, and dig deeper features for better control is to do better research. You just system two thinking, right? You're giving more test time scaling to get better answers. So I think that's where you'll also see a lot of papers coming in. Agentic RAG, I think that's where a lot of things are also changing. Agentic RAG is basically having this agentic layer, which is actually improving your RAG over time. Yeah, I think I'm done with the presentation. We can go through some discussion now. Yeah, there are some questions.
Hey, Raj, I have a couple of questions.
Yeah, go on.
Hey, firstly, great presentation, a lot of valuable inputs.
Thank you.
Just on the multimodal chunking, I just had one input. So today, Andrew Ng, landing.ai, they came up with this agentic chunking utility. It uses kind of like whatever you mentioned, right? Multimodality. So they use agentic reasoning basically to parse your PDF. So I thought, that's something interesting, and it just came out. I didn't try, but
Yes.
In terms of validation, I do have a question.
Yeah.
So we use a Judge LLM. Let's say it's completely driven by the LLM and not human in the loop. So you are putting another LLM to evaluate the response, and the response is being validated against your knowledge base, against whatever is in your vector store, right?
Yes.
So what if both my models, my generation model and the Judge LLM, Ideally, you want to keep them different, right? Not the same one that is generating the response. But what if both of them hallucinate? How do you actually know that, let's say the judge LLM says, yes, the response is accurate. It is, based on the context. But how do you know if both of them make a mistake? How do you find out?
Yes, I think that's a good question. I mean, it just having LLM as judge is all about scale. So you're just scaling that evaluation process. If having a human would probably not give that many examples or would not judge as many as having an LLM. Usually LLMs that are acting as judge would be better LLMs than the actual retrieval LLMs. Retrieval models are usually smaller models, which are only good at retrieving stuff, which is only fine-tuned to do a specific task at
Right.
pulling up your documents. And LLM as judge would probably these, if you see a GPT-4 evaluator, GPT-4 does have definitely can take a lot of cognition workload, higher cognitive workloads. I mean, when I say cognition workloads, it can do proper comparison. It can answer to basic questions to say if that is right or wrong, if there's a proper or apt in context or not. So I think those are something that it can done. But yeah, definitely there is a chance even that could hallucinate, but not as much as a retrieval model. It would probably be a parent model, and this could be a teacher model, but a parent model is usually a bit more robust than a teacher model. So, but yeah, there is a small margin for hallucination as well. But if you give proper hallucination usually happens if there's no proper prompt. If your prompt is not good. So there are techniques to do prompt optimization, like DSPy is having a self pipelines, teleprompters, the different techniques that DSPy provides where you can tweak your prompt and then check which prompt provides better results. So you can again do a bit of fine tuning for your model itself. And here, when I'm talking about fine tuning, it's basically prompt tuning that can be done in the GPT-4o models or any AI models, and then and that way you can make your system more robust.
Got it. But in general, the process that I just said, like for evaluation, right? So having a judge model, give it the knowledge base and let it evaluate, the original models, the generation models response. Is that how you would do the evaluation?
See, I mean, evaluation is actually done around if a question and an answer. Usually, the evaluation happens around maybe if you your LLM as a judge has a criteria. Let's say you have your model should able to answer questions related to a specific condition. Maybe, I'm giving an example about again an age related maybe a disease or something like that, maybe dementia. So how can it answer that question? So it gives you an output and it says, okay, this is the right answer, or it just retrieves the top K and top five answers. And if top one or maybe the highest probability answer is not the right answer, maybe it is in the top five, your LLM as judge would say, out of all these five responses, which one do you think is the right response? And if your response is in top fifth, if it is in top five, then you can make your model a bit better because your response went, you get your response in top five, and there's a chance that the user would not. It is fifth response, or the fifth chunk, which is not sent to the user. So you probably have to improve your model. But if it is in top 10, which there's a very high chance that you would get a completely out of context answer because you are only considering top five and your response is somewhere in top 10, it means that your retriever had done, or maybe your vector DB is not, or the way you're embedding into your vector DB it's lacking some metadata, or maybe there should be a proper graph that is created for this, and that's fine. So, but yeah, the exact way you have these LLMs answering the questions, you have a proper system prompt for your LLM, you craft that system prompt well and ask it a question on, is it a proper, but it's also domain tuned. Okay. The LLM as judge, that judge should also be based on your task at hand. What are you trying to do? It cannot be really broad. It cannot be a generic one, because generic one, there's so many things that you might miss. So
Correct.
you have
So
a
that's
specific
where,
answer. Yeah.
yeah, exactly. That's where I had a question. So do we fine tune the judge
Mhm.
models
Yes.
on our internal data, like, all the responses that we expect, or do we again make it like a RAG based where I hook it up with a knowledge base and it is also coming up with a response
No,
and then
we
you
can.
compare?
Yes, yes,
Yeah.
definitely. In that case, you see, it is basically giving you the, you could either, do that exactly as a RAG, or it can also give you the information. It can give you the source saying that, hey, this is wrong. This is the right source. So you
Right.
have that audit where you say, this is the right, and this is the right answer, and this is the wrong answer. But end of the day, when in the beginning phase of your RAG, if you want to improve your RAG just from like 70 to 80 or 90%, you probably need to even audit that as well, right?
Right. Right.
You have the LLM as judge, but you can't trust it 100%. But
Correct.
that is that scale. LLM as judge can give you a lot more examples, and iteratively your system gets better and better over time. And end of
Right.
the day, you also need to also have human feedback. If ever your human feeds like, hey, this is right or wrong, then you could also consider that as well alongside your LLM as judge response.
Got it.
Yeah. But yeah,
Cool.
this is a iterative process. But yeah, definitely there's room for even that get it can get hallucinate as well.
Yeah.
Stuff, it has a chance for that. Any more questions?
So the same question, Raj, regarding the Pawan asked it. The
Yeah.
LLM judge, I mean, it's like a RAG evaluation, right? So
Yes.
LLM judge means we got a response from our RAG system. I mean, whatever the RAG is there. So once we get a response, that response we are passing as a LLM as a judge method that contain the model. We are passing as input as well as the output along with the LLM judge will give a response that is called LLM as a judge. Just the context.
No, I mean, it is not happening during the inference time. It is not happening while we chat. LLM as judge is actually part of the optimization process. So you give a question, the model gives you an answer, but the LLM as a judge is happening like later on after the fact the answer is given. Now you have LLM as a judge, which is auditing all of these answers and responses pair, question and answer pair. Now you have LLM judge. Hey, this is the question, this is the answer. What do you think? This is the question, this is the answer. What do you think? And this is happening after the fact. And then that is used to optimize your model. That is used to optimize your RAG process. It is not happening during someone asks a query, and then it is not happening during the retrieval process. There is a way that happens as well. Here you see this GPT-4 evaluator. This is self-optimizing RAG. This entire thing is happening in the optimization phase where, it is not, it might be something happening in offline where it is only in the optimization phase, but, end user would probably have a lot of latencies here. End user would probably have a online retrieval model that is actually working. I mean, just like a typical MLOps workflow, where you have an online offline feature store. So just like that, you would have a retrieval model that is answering your question and retrieving stuff. But once this thing is done, you tap a separate process where this entire thing is happening. So and that is how it is this feedback loop is happening. But here they're using reinforcement learning, but usually this GPT-4 evaluator, it's able to evaluate this after the fact, and then we are saying, oh, our model is, or our retrieval model is actually hallucinating a lot, or maybe it is providing documents which are not relevant most of the times. Then what you do is you just go back and fine tune this retrieval model, or maybe you optimize your prompt, or maybe you optimize the way you embed or add more metadata and all of it after the fact. That that's you can do this processing. Hopefully I understand, answered your question. I don't know if maybe.
Thank you.
Yeah. Okay. Thank you. Any other questions? How many validations? It's from William, is saying, how many validations of information that agree and to what accuracy would be considered accurate from a specialized business model? It all depends on your business. So accurate enough, it's all up to you. I mean, it all also, in healthcare, definitely we want more accurate, but still human in the loop is always important. When you're talking about healthcare, you're not just relying on a simple AI to cure or give you a prescription. They should always have a human input to at least come out and give you a better response. But in terms of your chat model as well, you probably need high accurate. You don't want your customers to get wrong information. So definitely have to be as accurate as possible. I would say 99%. Ideally, I would say 100%, but I don't think the systems would be 100% right all the time. So maybe with reinforcement learning, yeah, they can be 99.99. Who knows? That is where we are heading towards. They could be a reinforcement learning model that can make it maybe 3 nines, 10 nines accuracy as well, maybe 2 3 years from now as these models improve.
By the way, thank you for the answer. The reason why I asked that is there's a lot of model developers that are going into specialties. Healthcare seems to be the strongest. And you and I know that your accuracy level has to be very high. But however, there are models that are being sold as we speak. And when I review and work with new developers, I'm just wondering, what level of accuracy. I want to make sure if I'm partnering with a model developer that his product is extremely accurate. And I don't know what extremely accurate is, whether it's 10 nines or what it should be.
Yeah. Yeah, absolutely. I mean, yeah, definitely there's you can't if it is healthcare, we are not relying 100% on it. Human in the loop, I always say human in the loop is definitely needed if it's really critical. Something like healthcare or financial space where we are actually making a decision that is affecting some outcome or some which will actually have a huge impact. So human in the loop is always needed. Expert opinion is always needed to come up with that number. To make the system more reliable. It's just about scale, right? We're not relying on RAG. Hey, this is a RAG and it can cure every disease. No, maybe, yeah, you're the doctor. And with this RAG, probably you can just, get so many things. You could probably give the best healthcare possible to your patient with very less time, doing a lot of this paperwork and wasting time, right? Yeah, you get information retrieval really fast, and it's end of the day, we are the managers for this AI. They are not the managers. We manage them. They are our tools. They're still tools to be used, And I'm 100% sure a calculator would give me the exact number, but I'm not 100% sure an AI would give me the exact answer. I mean, I'm still paranoid, and we should all be paranoid about AI. They can hallucinate. They can even cheat us. So yeah. Let's not trust these systems.
I appreciate the answer. One last thing, if you will. So sometimes we work with, and I hope I'm not, taking anyone else's time,
Right.
but sometimes we work with a new developer and they say, hey, we've got this really great product. Is there a process or a way of evaluating the accuracy of a new model?
So that entire thing is domain driven. So which domain what problem that you're trying to solve? I mean, if I come and say, oh, my model can solve this problem, specifically this specific problem, then, but how narrow is that domain, right? If someone is trying to say, hey, my model or my agent can actually go ahead and find the missing invoice and match it to your exact bill of materials that is missing. And, that is a narrow domain, and they can claim their AI agent is 99% accurate. And what is the business value that it gets in? Because GPT-4o, even there are smaller models which can do a lot more. I mean, you can also see the scale, because not just about how accurate, but also what is the cost, right? You could have GPT-4o or, the best model out there could probably give you high accuracy by doing multi-hops, going back, burning through these loops of tokens. Maybe you can get the 100% right answer every time you ask. but it's probably taking $4 or $3 every time you ask. And because you go back and ask multiple systems and come back and come to it. So you basically are creating these hierarchies or different, you're doing multiple LLM calls and then ranking the response to see which came up with the right answer out of 10 different API calls. If 8 come up with the same confidence score and 2 fail, then probably that is the right answer. So, but end of the day, you are consuming a lot of your tokens there, right? You're burning through this token. So how can you make or distill that knowledge into a smaller language model, which can do the same, which can give almost the similar accuracy as calling GPT-4 or these bigger models tens of hundreds of times to get the answer. But the small language model is more accurate. It is highly distilled with that specific knowledge, with that specific domain knowledge, and it can give 99% accurate. Then I would say, okay, that is the best model. That is what I was looking for, because its carbon footprint is low because it's budget friendly, and it is giving 99% accurate. Yeah, I might go with that. 1%, that's fine. I mean, it again depends on your business, right? And if for that 1%, you still have this human input, there is human in the loop to come up with a response, then I would say it's 100%, right? Because there's a human who would eliminate that 1%. So it's all about trade-offs. But yeah, you could have a small language model that can, and it's also domain tuned. So I don't think there are any vendors out there. They say, okay, I'm coming here to solve this exact problem, your exact business problem, unless it's onboarded in your own environment. And it has been going through this self-optimizing process through multiple hops, and it's been there long enough to be as accurate, then yeah, you can claim. So it happens over time, just like how human expertise builds over time. The same expertise would apply for these models as well. But a vendor coming and say, okay, my model is the best, then you should ask, where did you got my data from, right? And it would, because the data would be personal to you.
Just as a note, so vendors are going out to various industries, whether it be legal, whether it be finance, whether it be healthcare, and they're saying that their model will eliminate certain long processes, maybe in a project, removing a lot of the paperwork a lot of the time. Maybe in legal, saying we'll review the case to see if it meets litigation. And in medical, a lot of it is just paperwork, coding, and so on and so forth. But there are vendors that are pushing these solutions as we speak.
Yeah. There are a lot of vendors who are already pushing them, the solutions. Because if it's paperwork, I mean, businesses would only, I mean, when I was working for healthcare, the first problem that we were trying to solve was just finding out policies. We're developing solution for HR. We never went into patient care. We never jumped into any of Gen AI using patient data, because that's the last thing that we need to approach. But at least we able to summarize. Summarization is a simple problem. So what's wrong if you summarize and you missed out on something? I don't think you really miss out on a lot of information. You're just summarizing. You're just reducing time. You're making people more productive, but you're not coming up with any important critical decision there. So I feel like that's important. Which will have large impact. And paperwork optimization, I think there are a lot of products already there which will boost copilots to boost anyone's productivity, copilot to boost my productivity as a developer, or maybe your productivity as an attorney to retrieve better cases. Yeah.
Thank you for your time and your answers. I do appreciate it.
Thank you, William. Thank you for your questions. Yeah. Any more questions here? What are some of good resources or links or pointers to learn more about RAG implementations? So RAG implementation, there are a lot of sources online. You could just search them. I can also share some resources to implement a RAG. I mean, Dave, I don't know if you are a developer or what is your background, Dave?
I do have tech background, but tech consulting, non-AI related, but I'm trying to pick up on that. And
Yeah.
I did implement a simple RAG solution comparing policies with a document.
Yes.
But while learning in that process, I mean, it sparked some more curiosity around, how to implement these solutions.
Yes, I mean, if you're a developer, if you can write code, you can implement RAG. I mean, any developer can do AI because AI is just, I mean, when talking about RAG, it's more of LLM calls, but still what's different? Yeah, because if you know how to write an API, you know how to write Python, or even if you don't know how to write, you just ask a ChatGPT to give you a RAG code, probably give you, but only difference would be here is the integrations, right? If you're going with an enterprise integrations, maybe you're developing this RAG for your enterprise, then they could be different systems that you probably need to connect, right? You could have your CRM system that need to be connected to your new LLMs, and then you need to make an API call. The data security, network security, all of them comes into picture. But if you just want to do like a simple RAG locally, or there are a lot of resources already available, and if you're a developer, it's even better and you don't have to be an AI expert, but by any way. I mean, it's just simple API calls and all, but where building RAG is not that it doesn't take much time, but what takes time is optimization. What takes time is the evaluation, and evaluation and optimization is what takes time, almost 70% of your time.
Okay, I think I heard you mention like policies. For example, if you have policy, document, which is basically talking about different aspects of policies that are in place within an enterprise or within an organization or even law or medical. And on the other side, there is a document that was created to reflect that it is compliant with that policy. But now suppose we want to compare these two together. This is where I was a little bit struggling, the document that was filled out versus the document that is declaring the policies and rules. When I was trying to compare whether the policy is being broken in that document, for example, the filled out document, I was trying to figure out, do I store the policy document intelligently or just chunk it up? Intelligently in the sense, sections with JSON structure or some subsections, those kind of tree implementation. While the other one is more like a flat document that gets ingested, and then I want to compare. What do I do? That's where I was trying to struggle. I was struggling with when I was building the solution for myself, actually.
Okay, so so this is like so it's basically a form that the user fills, and you have this policies which you need to ground this form that is filled with.
Correct.
And then you're trying to check if that is you're basically trying to see if whatever that is filled is according to this policies or not, right?
Correct.
More of like,
yes.
yeah, more of like document crafting and creating a proper checking if that fill form is according to your policy or not. So in that case, yeah, in that case, you're basically putting some guardrails around your policies, right? Whether you around your forms, you're putting guardrails around your form. Hey, what are you comparing it against? Is it around different sections, like, because the schema, right? There should be a schema for your form. It is a structured schema, and then you have a policy, and your policy is also should be properly structured in with the proper metadata, because if your form has different sections and your policy is reflecting different aspects to different section of your form, how the user fills, then you should actually do that in a more intelligent way, because that all depends on how you do pre-process your policies, how you are trying to, because your retriever should be able to retrieve different sections and compare it against different sections. But
Correct.
yeah, but now you're giving this question. You're not just giving input as a question like, hey, can you tell me about this? You're not giving a chatbot, but you're doing more of a document processing where you're giving the input as a form, and then you have different sections in this form which are retrieved. So it should be a bit a different pre-processing step that need to be added, but it is doable. In that case, you probably need to make your RAG a bit more you probably need to create a bit metadata and have individual sections to be evaluated based on that policy grounding. So because your input is not a simple question, right? It actually has to be a filled form which has a structure, right?
Correct. Yes.
Yes.
Yes. So I was struggling with the terminology and how to, even describe this problem.
Yes, I mean, you could use Call Pali for that.
Okay.
This
Yeah, I
works
took some
really
notes.
well,
Okay.
because then just convert that to a domain of image. Don't work with text. Do that with
Okay.
Pali. I think this will do a great job. Just create your whatever policy documents that you have,
Mhm.
that as an embeddings, and create them in your vector DB. And now you have your PDF that is an input. And what happens is it just compares this with that, and it does the inference. So you're grounding all of your
Okay.
comparison happens with that. So now you're comparing images with images, right? That will be a multimodal rack, but this will work great. Call Pali, just explore this.
Okay. Yes.
If
Thank
I
you.
can,
Thank you. That's what I was
if
looking.
if I can just add, actually, we ran into a similar problem in finance. So I have finance background, and the way we approached is there are vendor tools like AWS has this text track service, which specializes in intelligent document processing, right?
Yes.
And
Yes.
these models that they use, they are specialized in various forms, healthcare, finance, right? And some forms are like, I mean, yeah, definitely you can build your own RAG, have some kind of chunking strategy. Call Pally can do it, or you can use like some of these products like TextRack that specialize in this area, and then you can have like a small language model like we just discussed and fine tune it on your policy needs that can act as a judge to see if the fields that were entered meet your policy requirements or not.
Yes, that's right. But test track would again do OCR, right? You again test track.
It will do OCR.
Yeah,
The
but
only thing is they specialize, like I said, because they're a vendor and they are in
yes,
that
yes,
space.
basically.
They
So,
train these models on like various forms, like healthcare, doctor notes, right? If you want to extract, instead of you having to go through those hoops, there is something that is already out there. Something you can explore. Definitely, self doable. If you are in that space, like let me build it on my own. I
yes,
think Call Pally is not a bad idea.
yes, yes. I mean,
Okay.
Tesla
Okay.
is
Actually, it's trying to build it for myself. Yeah, I have certain
okay.
aspects of my own domain. I'm trying to see what I can do. Yes.
Yes, I mean both. I mean, the test track is also a great service. AWS. I think AWS has this Comprehend service. So Comprehend
Okay.
has medical space, just like what Pawan was
Yep.
mentioning. They have medical. This is only trained on medical terminologies because, as I said, LLMs might be they are generalists. But AWS has built the system way before LLMs. Those are been there since 2020, 2021. That's when I worked on this services, both with Tesseract. Using Comprehend. They could be medical Comprehend. They could also be, I think, finance, I guess, right, Pawan? I think there's something specific to finance, but these are domain tuned. You have
Yeah,
some.
Domain data.
exactly. They have domain tuned models.
Yes,
That's why
yes,
I'm saying, like, if you have the skill set internally in your company and you have the dollars to build it yourself, I
yes,
think for sure. But for by just spending few dollars by making few AWS API calls, you can as well get it done. So
absolutely,
that's where I'm. Yeah.
Okay.
absolutely.
That's
That's a
it.
good answer.
Yeah. Thank you. Thank
Um,
you.
any other questions? But yeah, I'm definitely enjoying this meetup today. Definitely getting great answers, great questions from everyone, and also everyone is very collaborative in terms of answering and helping each other. So it's great having this session and enjoying every part of it. And thanks a lot, everyone. Great talking to everyone. I mean, have a great rest of your day. Thank you.